Hello and good happy Friday to everyone. So, number one, I dug up my old webcam while I was moving, and I think it has quite a better picture quality, so you can see a little bit more of my face. Not that it's much to look at right now because I'm in the middle of moving, so not putting a lot of effort here. But moving on to our notes for today, we're going to be talking about midpoints. So yesterday we talked about segments and how if you break a segment up into two pieces and put them together, you have one big piece. And we talked about some different kinds of problems that you could have where you have to figure, okay, piece one and piece two put together make the whole. Well, today we're going to be talking about a very special type of that called a midpoint, where it breaks those two pieces up into perfectly even pieces. So yesterday a segment could be this big and the other one could be this big. And those are two different sizes. But today we're going to be talking about those segments that are exactly the same because they're smack dab in the middle of the line. So let's get to it. I'm going to fill in my table of contents first. It is the 28th of August, 2020, and our topic is midpoints. That's going over on page 8. All right. So again, we have the 28th. Topic is midpoints. I gave you all a kind of brief introduction to our topic of the day, but let's start off with defining a midpoint. So a midpoint is a point on a line segment that is equidistant or equal distance from both endpoints. So for a little picture of what this looks like, perhaps we have our line segment A, B. Well, the midpoint is going to be exactly in the middle of these two. So say if that's a 2-inch line, I'm going to find exactly 1 inch in the middle and put my midpoint there. Now again, I always tell you guys, this doesn't have to be to scale because it's in your notebook. So just about the middle of it. And we're going to call that M. Our midpoint. Now, a few days ago when we talked about angles, I introduced you guys to congruency marks, which are a way for us to show that two angles are equal just by looking at them. And we would put one arc on each. Well, there's actually a way to do the same with line segments. If I want to immediately know, okay, well, if M is cutting these two into two equal parts, that means that AM and MB are the same length. They're congruent. So these tick marks are congruency marks. And recall, what does congruent mean? Equal, or having the same measure. So like I said, if this was a 2-inch line, then each of these would be 1 inch. Actually, I think I'm going to turn this lamp on. It's blowing out the picture just a bit. There we go. All right. You also could say that a midpoint bisects or cuts in half a line. So in the picture above, point M is bisecting line AB because it is cutting it exactly in half. So if you had a birthday cake and you cut it right down the middle in two perfect halves and you took one for yourself, you would have bisected the cake. All right, and in technical terms, we say if M is the midpoint of line segment AB, then from A to M is congruent to from M to B. So it's similar to yesterday where we have two halves that are making up a whole, but now we have that special property that the two halves are equal. So we may have similar problems from yesterday, but they're going to be based off an equality. So for a first little bitty example, let me do this in pink. I'm feeling pink. I'm going to do in words. So if M is the midpoint of QR, and QR equals 10, what is the length of QM? So I've always been very much a visual person. I like to be able to see things, and that's part of why I like geometry so much, because I can physically draw this problem out. So we have this line segment, QR. I can draw that. We have Q, we have R, and M is the midpoint. So that's going to be right smack dab in the middle, giving me two equal halves. And they're saying this whole thing is 10. Well, what's half of 10? So I was looking at my notes. So half of 10 is 5. I swear, I'm trying to record this video and I'm getting a phone call literally back to back. Please go away. Okay, just like a real class, huh? All right, so each side of the line would be 5. All right, so let's take it up just a notch. And this time I'm going to draw a picture. So if I have point F here, and point G here. And this is -2, -1, 0, 1, 2, and 3. We're going to ask, find the midpoint of FG. So here I can see that I've put it on a number line. And that's another way that we talked about that we could see a line segment. We looked at that yesterday. So the same thing works for when you're working with midpoints. If you're given a line on a number line or a line segment on a number line, you can use the numbers to count out to find the midpoint. It works really, really well if both the numbers are even or both the numbers are odd. If you have one odd and one even, what'll happen is if I try to count, okay, there's one in each direction. All right, there's one in each direction. I'm now stuck with no middle point. It's somewhere between 0 and 1. In fact, halfway between. So we would know that 1/2 is the midpoint. But what if you're not given a picture? I mean, if you're given a picture, it's fantastic, and you can count it out and find the 1/2 that way. But if you don't, then how you do it is you add the 2 points together and divide by 2. Essentially, you take an average. So -2 plus 3 divided by 2. And that will give you 1 on top and 2 on the bottom. And whoa, look, it is a half after all. So those are different ways that you can find a midpoint when you're dealing with one-dimensional distance, which is like on a number line. You can either use the number line to count, or you can use finding an average to add the 2 together and divide by 2. All right, let's turn up the heat just a little bit, shall we? With example 3. With example 3, I'm going to draw out a picture for us, just because the word problems take so much writing. So here we have line XZ with midpoint Y. XY is 10, and YZ is 2X. Solve for X. Then find the length of XZ. So based on our definition of a midpoint, I know that these two pieces are equal. And so I can set them up exactly that way. Half 1 equals half 2. As simple as that. So I can put 10 here and 2x here. And to solve that, I just have to divide both sides by 2, and we get that x is equal to 5. But again, in geometry, finding x isn't usually where we stop. We're using x to know something. And so if we plug it back in, we'll find that that's 10, which of course we should know, because if this is 10, that's 10. But I'm just working through this example to show you the process. So then when it says to find XZ, well, now we need to add up our two pieces. 10 and 10 would make 20. Again, I like to use simple examples so that everyone is able to follow along with the concept. But today, let's actually work through a pretty complicated example. So for this one, we have line segment RT, and right in the middle, we have our midpoint M. From R to M is 5x plus 9. And from M to T is 8x minus 36. And I'm going to want us to find what x is, and then what each piece is. So what's Rm? What's Mt? And what's RT? So clearly I have two different expressions here. So the setup isn't going to be quite as easy as this problem, but we're doing the same concept. Half 1 equals half 2. So I'm going to set it up. 5x plus 9 equals 8x minus 36. So again, half 1 equals half 2. Doesn't matter what my halves are, I set them equal. Now from here, we have to solve the equation. And that's when I say, hey, you should definitely look back at your notes, because we solved an equation just like this when we were solving multi-step equations on page 3. I dropped my pen. There we go. So this is where we had a variable on both sides. We moved one of the variable terms and then solved from there. So at this one, I have to decide which variable I want to move. And I mentioned in that lesson, I always like to move the smaller number because it makes my math a lot easier. So I'm going to choose to move 5x because it'll keep my numbers positive. That'll leave me with 9 equals 8 minus 5 is 3x minus 36. Then I want to get x by itself, so I'm going to add 36 to both sides. And 9 plus 36 makes 45. And I'm left with 3x. Lastly, I divide out the 3. And I get 15 equals x. So I can go over and fill that in. But again, usually finding x is not the end game for us. We want to figure out what each piece is. So that's where we can go back in and substitute. So maybe I want to figure out what Rm is. So I'll do 5 times 15 plus 9. Well, 5 times 15 gives 50 plus 25, 75. Plus 9 more makes 84. Now, I wonder if some of you are thinking that you may already know what MT is. All we did was solve for RM, so how might we know what MT is just from that? Think. Oh yeah, that's right, they're both the same thing. RM is the same as MT, so we could just write 84 there too. Now the only reason I'm not is this is a great way to check your work and make sure that you solved it correctly. Because if I solve it or substitute in for MT and I get a different number, that tells me that I didn't do my work right. Now, of course, if you're trying to go fast and save some time and you're pretty confident in your work, then you can go ahead and say, hey, they're both 84. But this is just a nice way to be able to check your work because you have two different expressions to work with. All right, so 8 times 15, ooh, that's a big one. 8 times 10 is 40. Or, I'm sorry, 8 times 10 is 80. 8 times 5 is 40. And 80 plus 40 is 120. And then that's minus 36. And that brings us down to 84. So this tells me I did do my work correctly because I got 2 equal halves. And lastly, RT. Now I could plug into 5x plus 9 equals 8x minus 36 and solve a really long expression, but I could just add up my 2 halves. 84 plus 84 makes 168. So there was an example of a pretty complicated one, and hopefully that's helpful for you guys as you head forward to do your assignment for today. Just keep in mind that whenever you're dealing with midpoint, it is cutting that line exactly in half. So you can always treat the 2 sides as equal. So a lot of the time you're going to be setting up equations where 1/2 equals the other half. Now, just as a bonus little tidbit to wrap things up, there's actually another problem type that comes from midpoints that we may see later, and if we do, I'll prepare us for it, but not quite today. And that is where 1/2 of the whole equals 1 piece. You know, I'm trying to find a better way to explain this. All right, let me do one with a picture. That might be a little better. All right, so if we're dealing with this situation, we know that AM equals MB, and that's how we were setting up our equations. But what if they give you that this is 2x minus 5, and that MB is 3x plus 4? Well, we don't have 2 things that we can set equal. And please never ever set a half equal to a whole. Because if I ordered a whole cake from the bakery and they gave me a box with half a cake in it, you better believe I might go Karen on some people and be like, where's the rest of my cake? I want a whole cake. So do not ever set a half equal to a whole. Instead, you have to compensate and say, okay, well, 2 of these will make up the whole, because if MB is 3x plus 4, then AM is 3x plus 4. So these 2 things together will make up our whole. So you can either write that 2 ways. You can add up 3x plus 4 and 3x plus 4 equals 2x minus 5. Or since they're both the same thing, you could say 2 3x plus 4s equals 2x minus 5. Now don't worry, we don't need to go and solve this all the way through. I just kind of wanted to plant that seed in your brain because this is a problem type that we will probably end up seeing in the future, and I want to start stressing early. Whenever you're in geometry or anywhere in life, do not equate a half to a whole because you will have a lot of angry customers. If I order a whole pizza and the delivery man gives me half a pizza, I'm going to be calling someone saying, hey, I think my delivery man ate half of my pizza on the way over. I paid for a whole pizza, where it at? So make sure you're not setting a half equal to a whole. You can set 1/2 equal to another half all day long, but do not set 1/2 equal to a whole. All right, that's all I got for today, and I hope you all have a wonderful weekend, and I will see you or hear you or however on Monday.